Well, this is my second class on age level chemistry. Now I'm going to discuss about atomic structure. Hopefully this class will help you a lot. Well, first of all, I'm going to discuss about the fundamental particles of an atom. I'm going to discuss it briefly as these topics we have already learned it in O levels. So the same topics will be repeated in age levels. First of all, the basic characteristics of the subatomic particles of an atom. An atom contains basically three fundamental particles. These are proton, neutron, and electrons. We must have to remember the characteristics of these particles, like their relative mass and their relative charge. Well, I'm going to change the slide as we have already learned it in O levels. Hopefully, I do not need to repeat it again. Well, then the very important characteristics of atoms, that is atomic number and atomic number and mass number. Well, atomic number, we know that the number of proton, and it is denoted by Z, and mass number is the sum of the proton number and neutron number, as these two particles exist inside the nucleus. So the mass number is also called nucleon number. Here the example is showing in the slide. Okay, I'm gonna change the slide again. Now, isotopes. Isotope is a very important characteristic of atoms. In isotopes are those atoms which have same number of protons but different number of neutrons. As the number of protons are same, we can see in the figure, so they should supposed to be the atoms of the same element. Excuse me. The neutron numbers are different here. Due to the different neutron number, their mass number will be different. We know the chemical characteristics of atoms depend on atomic number, that is proton number. So isotopes should have similar, same chemical properties. But as the neutron number is different, so mass number different, their physical characteristics will be a bit different, like melting point, boiling point, but they will show the same chemical properties as the proton numbers are same. Well, I'm going to change this slide again. So here a mathematical problem is given. Here we can see two isotopes of chlorine. And different isotopes exist in the different amount in the nature. Chlorine 35 and chlorine 37 are the two atoms of chlorine. Chlorine 35 exists to 75% and chlorine 35 exists 25% in the nature. So what will be its average relative atomic mass? Sorry, I'm not going to show the mathematical solution of the mathematical problem in this slide. I'm just giving the example. The mathematical problems will be shown in the later slides. So we can draw the two atoms of chlorine in this way. Okay, the proton number are same, 17. Electrons number will be same as well, as atoms are electrically neutral. So the proton number and electron number should supposed to be the same. But then you can see the neutron numbers are different. Here the neutron number of this chlorine is 18. Here it is 20. Again, the three isotopes of carbon is showing here. Carbon 12, carbon 13, and carbon 14. Then Newton numbers are different. Proton numbers should supposed to be same. Well, now the very important topic of this chapter, that is mass spectrometry. Mass spectrometer is a kind of machine which is used to find out the relative atomic mass of different atoms. It's a very complex machine. We are not going to explain the structure of the machine. We will just know the basic characteristics of this machine in our syllabus. The requirement is to know the properties of the different parts of this machine. We do not need to know about the entire mechanism of the machine. That we do not need to know here. In our age level syllabus in Cambridge, it is not included. Only the basic characteristics of the different parts of this machine is included. Well, let me show the different parts of this machine. This is a mass spectrometer. The definition of the mass spectrometer is given here. A mass spectrometer is used to determine the relative isotopic mass and the relative abundance for each isotope in a sample. Okay. Well, first of all, the sample, I mean the elements of which we want to find out the relative atomic mass of its atoms, that element will be, the particles of the element will be vaporized first, and then it will be injected into this mass spectrometer. So first, vaporization. Excuse me. Then the particles will be bombarded by the high speed, it is called electron beam. The electrons will strike the particles and will split the electrons from the atoms. You can see in this figure, when the electrons are striking from the top, the particles will be transformed into positive ions. That means the electron will strike the particles with very high speed, and as a result, electrons will split from the atoms and it will be transformed to positive ions. Then our next work will be to make sure the positive ions will move forward. And to make sure we have to use two charge plates. Those are called electron plates. And this section is called acceleration section. The charged particles contains electrons, and those electrons will attract the positively charged ions, and as a result the charged particles will come forward and get inside the tiny hole of these charged plates. Well, our next section is called deflection section. Here, two heavy magnets are used to make sure the deflection of the charged particles. Here the machine will measure the mass charge ratio, M/Z ratio, which is called mass charge ratio. That means if the charge of the particles are more, then the mass charge ratio will be less. If the mass charge ratio is less, then the particles will deflect more. And if the mass charge ratio is very high, then the particles will deflect less. So here we can show three different types of mass charge ratio. then 3 different types of beams will be deflected and it will pass the detection chamber. In detection chamber, the particles will be again transformed into atoms. The charged particle will be transformed into atoms and it will strike the detector plates. As a result, on the computer screen, we can see the different bars of the isotopes. We will discuss more about these bars, which is shown in the graph, and we'll analyze it in our next class.